Welcome to Edupedia World Videos. In our today's lecture, we will discuss classification of elements, in which we will discuss Dobereiners Triads and Newland's law of octaves. Till today, 117 elements are known to us. The most fascinating aspect of these elements is the diversity of chemical reaction shown by them and their compounds. The idea of classification of elements to treat adequately the chemistry of all these elements without developing separate set of rules and theory for each element. The periodic classification of elements has given us a systematic and immensely useful framework for correlating the properties of the elements into a few very simple logical patterns. The elements are systematically arranged in rows and columns with increasing atomic numbers, and space has been reserved for future elements to be discovered. We are in a position now to predict the properties of an element and its compounds from its position in the periodic table. About 30 elements were only known with different properties around 1850. Although a lot of information about these elements and their compounds were available, there was no apparent order. In 1817, the German chemist John Dobereiner noticed that there were sets of three similar elements called triads in the order of increasing atomic mass, in which the atomic mass of the middle element was approximately the arithmetic mean of the atomic masses of the other two elements. The middle element had properties in between those of the other two. Such groups of elements were called Dobereiners Triads. The examples are alkali metal group. Lithium, sodium and potassium have similar chemical properties and form a triad. Sodium has the properties in between those of lithium and potassium. They have similarities in chemical properties also, like they are all metals. They all react with water to form alkaline solutions and hydrogen gas. They all have a valency of 1. Their carbonates are resistant to thermal decomposition. Second is alkaline earth metal group. Calcium, barium and strontium exhibit similar chemical properties and form a triad. They have some similarities in chemical properties, like they are all metals. The oxides of all these metals react with water to form alkaline solutions. They all have a valency of 2. Their hydroxides are resistant to thermal decomposition. Third triad is halogen group. Chlorine, bromine and iodine exhibit similar chemical properties and form a triad. They are all non-metals. They all react with water to form acids. They all have a valency of 1. They all react with alkali metals to form a neutral salts. Chlorine, bromine and iodine are the members of the halogen group, and they are called halogens because they are salt producing. Dobereiners triads are not confined only to the elements of the same group. They can be members of different groups too, like lithium, beryllium and boron. It was observed that Dobereiners classification was not applicable to all known elements but was limited to only a few elements. Hence, it was abandoned. But credit goes to Dobereiner, since it was the first attempt to seek order among the apparently disordered collection of elements. Newland's law of octaves. After the discovery of Dobereiner about the relationship between the atomic masses of elements, other chemists got encouraged to find order among the elements. The first landmark attempt was by an English chemist, John Newland, in 1864, who was also a lover of music. His law of octaves states that when elements are arranged in the order of increasing atomic masses, the physical and chemical properties of every 8th element are a repetition of the first element. He divided the elements in the order of increasing atomic masses into horizontal rows of 7 elements. The repetition in the properties of the first and 8th element is just like the repetition of the 8th note in an octave of music. Newland's above law is called the law of octaves. The fundamental importance of Newland's law was ultimately appreciated and recognized much later by the Royal Society, London, by awarding him the Davy Medal in 1887. Although some marked inconsistencies existed in this classification in Newland's time because of inaccuracies in the atomic mass data. Thank you for watching Edupedia World Videos.